In an attempt to explain imaginary numbers, let's start with something we know. What is the square root of 1? Well, hopefully you got 1, but what happens if you try to compute the square root of -1? You know it's not -1, and you know it's also not +1. So what is it? In fact, what is the square root of any negative number? Because if you put the square root of any negative number in your calculator, you get a math error, which doesn't help us at all. In short, mathematicians don't know exactly what this type of number is, or what it means. But somehow, they don't need to. Because in an almost elegant way, mathematicians have used it as a tool to make incredible advancements, without knowing what it physically means. We call these imaginary numbers, with its base unit being the square root of -1. We denote this as I, for imaginary. Simply put, without this number, you wouldn't have phones, video games, or most modern technologies available. Using imaginary numbers to solve problems is like jumping into another dimension to solve a real-world problem. We don't know exactly what this other dimension is, but we use it anyway to solve problems in our dimension. So what are the basics of imaginary numbers? Let's start with their powers. As we know, I to the power of 1 is equal to the square root of -1. This means that I squared is equal to -1. I cubed is the result of multiplying I squared by I, which is just -1 times I, or -I. This leaves I to the power of 4 being the result of I cubed times I, which is the equivalent of -I times I. This simplifies to -I squared, which is just -1, which is +1. These four expressions lead to a very interesting pattern, because now I to the power of 5 is just I to the power of 4 times I, which is 1 times I, meaning that I to the power of 5 is equal to I. This means that I to the power of 6 is I squared, I to the power of 7 is I cubed, and so on. You can see how the unexpected simplicity of imaginary numbers could help in solving harder problems. Imaginary numbers are also used to slightly simplify negative roots. For example, the square root of -4 is equal to the square root of 4 times the square root of -1. This is equal to 2i. One of the last basics of imaginary numbers is in defining the imaginary solutions of equations. For example, let's solve x cubed plus x equals 0. If we factorize and use null factor law, we find that our solutions are x equals 0 and x squared plus 1 equals 0. By rearranging, we can see that x squared equals -1, and therefore x is equal to plus or minus the square root of -1, which is just plus or minus I. While these are the main basics of imaginary numbers, this is not the end of their applications. Their story continues on with complex numbers, which is what happens when you combine both imaginary and real numbers. This is where imaginary numbers truly gets interesting.